going to begin the respiratory system. This week we're going to spend 2 days on the respiratory system and 2 days on the excretory system. These are kind of combined into one chapter, so I've just broken it up. Half the week we're going to do respiratory, and then the second half of the week we'll do the excretory system. So let's go ahead and get started. Today is the respiratory system. The respiratory system has two main functions. The first one is to provide a constant supply of oxygen and the removal of carbon dioxide. The second is to aid in waste removal and regulation of body temperature. So if you've noticed, plants are the opposite. When we learn about plants, we learn that plants breathe in carbon dioxide and breathe out oxygen. Humans do the opposite. We breathe in oxygen and breathe out carbon dioxide. This is the upper respiratory system here, so I'm going to just go through this real quick. So I'm going to trace the passageway of air real quick here, and then I'll go through this part. So one, the air is going to travel through your nostrils, into your nasal cavity, and it's going to go all the way down like so. So let's go through this. Inhaled air rich in oxygen enters through the nostrils. It then goes through the nasal cavity, which has many bumps and ridges called turbinates that disrupt the airflow, slowing it down, allowing it to be cleaned, warmed, and humidified before going into the lungs. That's really important. I'll come back to it. It passes through the pharynx, and then it goes past the uvula, which is like the little dangly thing at the back of your throat. Then it goes past the epiglottis, into the glottis, through the larynx, which is also called your voice box, and into the trachea. With this point here, I wanted to stop on this one because the reason why it needs to be slowed down by those turbinates, those little bumps in your nasal cavity, is because the air needs to be warmed up a little bit before it reaches your lungs. If it wasn't warmed up, think about if you're breathing really cold air on a cold, snowy Minnesota day and the air didn't get warmed up and it hits your lungs could freeze. But since the air takes the time to get warmed up in your nasal cavity, then the air that hits your lungs is not as cold, so your lungs won't freeze. Another note on this, just real quick, is if you're breathing in air that had lots of little particles in it or toxic fumes, your nasal cavity helps clean it before it hits your lungs, so that way it doesn't damage your lungs. Obviously, it can't filter out everything, but it does filter out most of it, which is pretty amazing. And it also humidifies it because if you're just breathing in like straight air without having any humidity in that, then your lungs could actually dry out. But we need to have moist air hitting our lungs so that way our lungs don't dry out. Lower respiratory system. So the trachea, which is this guy right here, kind of looks like the bendy part of a bendy straw. It's a 12-inch rigid tube. It's held open by cartilaginous rings. The inner lining has ciliated epithelium, and it branches into two bronchi, or bronchi, some people say. We learned about cilia in the beginning of the school year when we learned about cells. Remember, cilia are different than flagella. Cilia are a bunch of little tiny hair-like structures. This is what the inside of your trachea looks like, so the inside right here. And they're made out of cartilage. Remember, cartilage is more flexible than bone, so your trachea is actually pretty flexible. The lower respiratory system, now talking about the lung anatomy. So you've got something called bronchi, which continue to branch into smaller and smaller bronchioli. At the tips of the smallest bronchioli are grape clusters, which are structures called alveoli. Each lung contains greater than. I always get mixed up on those. The less than symbol, though, makes like an L shape. That's how I remember it. So each lung contains greater than 300 million of these microscopic alveoli. So these are just some diagrams showing you a little bit of the lung anatomy and the alveoli. And the reason why they call it grape clusters is it kind of looks like grape clusters. All right, this is talking all about breathing. So when you inhale, so go ahead, everyone, take an inhale. All right, what did you just do there? Well, this is the active phase. Your intercostal muscles, also known as your chest muscles, contract and expand the chest wall, and the diaphragm contracts. This causing This causes larger volume in the lungs and lower pressure than atmospheric pressure, and the air rushes into the lungs. So this gets into a lot of science and physics here, or a lot of obviously science, because this is a science class, a lot of physics here. So I'm not going to go into all of it, but your lungs can actually create a negative pressure. Your diaphragm aids in that as well, but I won't get into all that detail there. But when you inhale, so everyone go ahead and inhale, hold it for just a second, and you've probably felt your chest expand. Okay, you can let it out now in case you're holding your breath. And then when you exhale, this is the passive phase. So both your chest and diaphragm relaxes, causing air in the lungs to be pushed out. So that's the passive phase. Inhaling is the active phase. There's something called the pleural membrane, and this isn't plural as in like English class, singular versus plural. This is plural as in pleural. The pleural membrane. Each lung and chest cavity wall is surrounded by a thin, moist pleural membrane. It's just a membrane near your lungs. It's a sticky membrane and it acts like glue, holding the lungs against the inner chest wall. So without the pleural membrane, your lungs would just kind of fall. They need to be stuck in your chest, right? And it helps to prevent your lung from collapsing. So if they weren't stuck to the inside of your chest wall, they would just collapse and you would feel like you're suffocating because you wouldn't be able to breathe. These are just a list of some lung diseases. I left these in here so you could look at them. So pneumonia, bronchitis, asthma, emphysema. You've probably heard of these before. Also, a quick note, if you ever see anything that ends in itis, I think I've talked about this with you guys before, but it's Latin itis for inflammation of. So it should make sense that bronchitis is the inflammation of the bronchi or bronchi. All right, that brings us to the end of the respiratory system. This section was really short because this chapter is broken down in 2 systems, so that's why this system seemed a little bit shorter. But we'll be doing an activity on the respiratory system today and tomorrow, and then we will start the excretory system, which we'll be working on that for 2 days as well.